Hello. In this video we're going to talk about exponential equations or exponential functions. We're going to use 2 points to write exponential functions. Now we have a skeleton equation here, y equals a times b to the x. A and b are listed as constants. That means we're going to change a and b into numbers, while x and y will remain letters because they have to vary, while a and b will remain constant, as it says. Also notice that the exponent of x is on the base b, so it's b to the x. The a has an exponent simply of 1. We don't see it. The x only applies to the base b. So in number 1, we want to write the equation for the exponential function, and it's going to go through 0, 2 and 1, 10. So let me start with our skeleton form, a times b to the x. Now, I'll go with 0, 2 first. If I put in 0 for x and 2 for y, so 2 equals a times b to the 0 power. Well, we know b to the 0 is 1, so we have 2 is equal to a times 1, so a is 2. So we already know what a is, we just need to figure out what b equals. So I can rewrite this for right now. Right now I have y equals 2 times b to the x. And let's look at 1, 10 now. So if I put in 10 for y and 1 for b, well, b to the first, anything to the first power remains the same, because I'm just multiplying it by, it's itself, right, because I only have the 1b there. Then I could divide by 2, and so b ends up equaling 5. So my final equation here, a is 2, b is 5, and it's raised to the x power. Y equals 2 times 5 to the x. Let's look at another one. In this function, we're going to go through 0, 6 and 2, 54. So let's again start with y equals a times b to the x. And I'll again start with 0, 6. So we have 6 equals a times b to the 0. Once again, b to the 0 is just 1, so we have 6 is equal to a times 1. And so a must be equal to 6. Perfect. So we know that y is equal to 6 times b to the x. Now both times we've been given a point that's been 0, something here, and we can talk about where that point is, right? In this one, 0, 6 lies there. In the first one, 0, 2 was here. These are y-intercepts. So these are, that's written in ordered pair form, and this is written graphically, but they're y-intercepts. So in both times, the first one, a was 2, and in this one, a is 6. So we can say confidently here that a in this must be the y-intercept. Okay, a is our initial value in an exponential function. It's what we're going to start with, and then we repeatedly multiply by our number. In growth and decay form, it would be the principal of our investment or the starting population for our town before we grow or decay our population. All right, let's continue on with this. So let's look at 2, 54 now. And so if I go 54 is equal to 6 times b to the second, I'll divide by 6. So we have 9 is equal to b squared. And when I square root both sides, we know that we should have that plus or minus, so b could equal either 3 or negative 3. But our exponent, or an exponential function, if we have a negative there, we're going to repeatedly, when we repeatedly multiply, we're going to be changing from positive to negative and back again. So we're going to ignore the negative version of this. We're going to stick to where a consistent output is what we get, where we repeatedly multiply, and we're going to either stay positive all the time or stay negative all the time. So my b is going to be 3, and so I'm going to put another note over here. The b value has to be greater than 0. Okay, we want b to be a positive number. Okay, so let's actually write the equation here. We have y is equal to 6 times 3 to the x. Okay, that's how we write exponential functions. For now, we are done.